introducing our keynote speaker for this afternoon. And today's keynote is going to be delivered by Trevor Tailor. And Trevor is with the Open Geospatial Consortium, Director of Member Services, Asia and Americas. He'll be talking to us today about open data, open standards, and open proprietary technology, critical components in the evolution of geospatial information management. As a way of introduction, Trevor is currently responsible for services for Asia and the Americas, has over 25 years of experience in the International Earth Observation Community with a background in geography of Carleton University in Canada. Mr. Tailor has worked with Canada Centre for Remote Sensing, DIPEX Technologies, Interra, now Intermap Technologies, and PCI Geomatics. If you're not familiar with the term across the border in Canada, when they talk geospatial, GIS, they're using the term geomatics. Whereas last position was Director of Business Development with a focus on Central and South America. Mr. Tailor has significant global experience in a wide variety of technical, client services, project, business, and strategic planning activities. Mr. Tailor was PCI Geomatics business contact to the Open Geospatial Consortium for the past decade, representing PCI and OGC interests at the technical, principal plus, and strategic levels, particularly in South America, India, China, and Western Europe. Please join me in welcoming Trevor Tailor, all the way from Toronto, Canada.
First of all, thanks for the opportunity to present at this interesting and unusual type of conference. It's really nice to see a focus on collaborative efforts, because after all, that's what OGC does. And I'd be really curious to know what the results of the experiment are, Steve, if you wouldn't mind sharing that after the fact.
Well, certainly.
You know, this worked perfectly prior to me getting up here, so I must be special or something. Okay, let me ask a couple of questions. How many people are aware of OGC and the Open Geospatial Consortium by hand? How many people are aware that KML is an OGC standard? It's pretty impressive. How many people are members of OGC? Wow. So I know there's at least 4 or 5 in the room, but you may not know. And how many people are aware of how OGC works? Okay, this is good. This is, once we get my presentation fired up, this is going to feed nicely into that. How many people are aware that OGC has standards beyond web map service, web coverage service, KML, and catalog services? Okay, that's good. I'll just move this a little. How's that? Okay, that's fine.
That's the last slide in my deck.
I can dive into it. This is a big mouthful, this title, because I'm a standards guy and we have to use more words than we're supposed to. What my intent here is to do two things. Is one, explore the ecosystem of all things open and proprietary. And secondly, talk a little bit about one way the community got together to create a way around the difficulties of understanding somewhat obscure technology and terminology. I should probably start with talking about what a standard actually is. This is what lots of people perceive when they think about the standards process. Boring, slow, a headache. In the OGC context, we certainly are a slow organization, and I'll show you that a bit more. However, standards underpin everything. There's a reason why you can put a light bulb into a socket, why you can get money from the ATM, why my weird Canadian phone works here, or actually all over the world, and of course GPS lat long. So what is this document? A standard rather. It's a document that is created by, back to the collaborative concept, by a consensus, where a group of people, back to Steve's comment about people, sit down and figure out how to work together and what should be in that standard to overcome the upside down guy in this graphic. Process. If it isn't a consensus process, the end result is not a standard. There are tons of different types of processes. OGC has one particular way of doing it. There's 7, 8, 9, 10 different methods. IETF, the Internet Task Force Standards, uses something called a hum, where people actually, when they agree with something, they make a noise. And then I don't know how they measure volume, but it works. It's not easy. You can imagine when you have people from industry, people from government, people from academia, people from research sitting down with similar agendas and maybe some fundamental differences to come to a consensus can be kind of rocky. It's got to be transparent and open, and information needs to be shared. This is the people aspect of it again, about how things get done. So we have a formal voting process. It's one vote per member. It doesn't matter if the member is a company with 3 people, or Google, or the National Geospatial Intelligence Agency. It's one vote. There's a democracy to this process. Any and all no votes, so if somebody says, no, I don't like that standards, they all have to be dealt with, they all have to be answered, and they all have to be overcome before a standard can actually proceed. The goal is to make things interoperable. Followed a couple of things here. But in order for this to be successful, there's a relationship of open data, open standards, proprietary technologies, with a policy aspect to it. All of these aspects have to be sorted out. Actually, my favorite graphic is the one up here on my upper right. I don't know how many of you have looked at an architect's plan before, but back in the days where they did manual edits, that's actually a bubble that was written on the plans that somebody determined needed to be actually made and constructed. So the bridge is also one of the easy ones. We do have a lot of built environment people doing good work in OGC as well. All right, open this, open that, and the other thing. Open is super ubiquitous. It's everywhere. Open source, open standards, open data, proprietary technologies. There still remains a lot of confusion amongst these various phrases. I often get asked how my open source project is going. I'm not in the open source community. So I thought I'd spend a few minutes just going sort of like open this, that, and the other thing 101, just to clarify any sort of confusion. So what's an open standard? Freely, publicly available. Anybody should be able to have access to it anywhere in the world, no license fees. Vendor neutral and data neutral. We can't have vendor technology inside a standard, or vendor IP inside a standard. It's going to be defined, documented, and approved by the formal consensus process, and it cannot be controlled by a single entity. So I'm sure people have always seen this Delaware one before. How did the industry standards meeting go? Did you convince 83 companies to adopt standards that benefit only us while dooming the entire industry? Or are you a complete failure? Open data. So there is actually a fair bit of confusion about this. Once again, open data it needs to be available and accessible with only a reasonable cost associated with that. Sometimes it's the cost of duplication of media. Reuse it and redistribute it. So if you're going to make your data open and follow 100% open data policy, you must allow your data to be reused, repurposed, and then redistributed. And everybody must have access to it. And by default, in an open data policy world, any type of data is assumed to be open, unless there are strong arguments not to have it open. A lot of organizations around the world right now, India is actually a really good definition of that. It's direct opposite. Everything is closed until somebody decides it needs to be open. So the US, of course, is one of the global leaders in the open data. Policy, here's the policy word again. But it's not just there. There's lots of initiatives around the world. I've highlighted a few. Canada, Australia, Japan, Korea, Taiwan, and many other places. And I included a quote from a Korean fellow. Open data policy means changing substantially how government is working, not just increasing the meaningless quantity of data. Associated with this is, in order for an open data policy to be successful, it has to take into account two things, at least two things. One, that you need somehow to enable that open data, open standards, through technology. I know of one country in the world who I shall not name who announced a national open data policy, but just try to find the data. You can't discover it. How do you get it? No one actually quite knows, but they have an open data policy. The second aspect of this is people. The whole open movement is transforming how people think and how business processes work with that. If you have people in the organization who are not supportive of the whole open aspects, be it open data, open standards, then you might find yourself a little bit dead in the water. So people need to shift. The gatekeepers sometimes need to be removed from the gates, or somehow otherwise convinced. Because as you know, if a policy comes down from, I'll give a Canadian example. If a policy comes down from the federal government in Canada to the Department of Natural Resources that says, thou shalt be open, and yet the gatekeepers in that department don't feel that this is a good idea, they might feel threatened, then bureaucrats are really, really good at doing a lot of nothing while looking like they're doing a lot of stuff, i.e. maintaining the status quo. The good news is Natural Resources Canada is the direct opposite. Everybody from top to bottom are huge believers in open stuff. Open source. So it doesn't just mean access to the source code. And I have noticed that there are some demonstrations of open source here today and tomorrow. You must freely be able to redistribute the code. It always includes the source code, allows modifications. You can build your own version and distribute it. Once again, no discrimination. Everybody and anybody should be able to download the source. May not restrict other software, and must be technology neutral. Example, this is the open source Geo Foundation, which is a foundation that incubates and distributes various open source products, as well as curates some of them. So, there is a thought out there that open source and proprietary technologies compete. This isn't the case. And I'll say a little bit more of that momentarily. Source code cannot be viewed. This is where the vendor money is with the IP for GIS, geospatial remote sensing companies. You may be able to, a proprietary company might give their product away free, but you still can't get at the source code. So, OGC vendor members support both open standards and architecture to enable interoperability for their clients, another bunch of words. To simplify that, our community consists of the Esris of the world, the MapInfos of the world, the Intrographs of the world. I'll miss somebody because we've got over 200 vendors. But it also consists of members of the open source community. What's really cool is for the vendor side of stuff, Trevor is a member as well, so is Leica Geosystems. What's really cool is you have companies that go out and fight for business every single day on the street, compete like mad. But when they come to the OGC process, they cooperate with no issues whatsoever. Our process is really a nice neutral location to get stuff done. So we've got, as I mentioned, 40% of our members are commercial, a combination of technology vendors, service providers, systems integrators, and so on. And there's a link for the full list. So how does this all fit? Classic boring triangle diagram, but it does the job. The bottom of the pyramid, you've got standards, some metadata, web services. Halfway through the web services, we move into open source and proprietary technologies, all the way up to the user at the top of the triangle. So, examples. Local. This is an example from the city of Toronto. It's based on a combination of proprietary technologies, in this case, Esri, part of the Esri stack, as well as open source. And basically, in this case, this is only a small part of the portal, but it's well-being mapping, where are the hospitals, and so on. The city of Toronto did is they decided to change their architecture and start by using location as the central pillar of their engineering philosophy, which was kind of cool. So they pulled together 21 different departments that had something to do with location. National, this is the UK Met Office. This OGC members are global in scope. Nice quote from the head of applications development at the Met Office. Essentially, he says they cannot deliver the services to the public the way they need to deliver them without use of OGC and other standards. And global, the group on Earth observations. They're in the process, they just started their second decade of building the group global Earth observation systems of systems. And there was a quote earlier from the executive director. But this portal, you can go and find all sorts of really interesting resources from around the world. All right, so I mentioned earlier that there's some thought that proprietary technology and open source technology are basically fighting for the same pie. This actually isn't the case. It's a really big tent. There's room for everybody. In fact, with the advent of open source for geo stuff, it's actually making the market bigger. It's growing the market. because a lot of organizations who could not initially afford the upfront investment from Proprietary may start from a different path. One more aspect. Open does not necessarily mean access to everyone. It's a policy decision and an IT decision. You can run behind a firewall. So, for example, the UK Met Office has a defense weather and MGE. Alright, so OGC. I'll let you read the slide while my voice recovers from whatever just happened. Must be a frog or something. So, we're 21 years old, 515 members worldwide, 40 standards, thousands of implementations, and a lot of collaborative activities with other organizations. Here are some sample commercial members. So, as I mentioned, all the way from small organizations to giant organizations. Some governments. Thank you very much. So here's some government organizations, as well as 100 universities and more of research. Key point, alliance partners. We are not trying to reinvent the wheel. So what we do is we connect with many other standards development organizations and associations to make sure that they're harmonized. So for example, MISMO. Anybody know what MISMO is? That is the Mortgage Industry Standards Organization, because they understand that there is a need to ensure that when they go about their daily business, that location is taken care of. So, OGC has 4 programs. We have the interoperability program, which is where we actually do engineering. OGC is a little bit unique in that before a standard can be adopted, it has to be tested, i.e. demonstrated, running code, and people must promise to implement it. There's a standards program. We also have certification and a marketing and communications program, which is one of the reasons why I'm here. I'll give you some examples of the interoperability program. These are pilots. We currently have 4 underway. We have our annual OGC test bed, which is where a lot of basic research gets done. We have a pilot running on Arctic spatial data structure. We have a pilot running on the Internet of Things for first responders and with DHS and some other partners. And we also have a smart cities pilot underway right now. So, what do you think of that? This is a good summary of everything I've said so far. All right, so the whole point of this slide, well, it says 2 things. That there is a wealth of OGC standards. In the box to my right, a lot of people think OGC standards are all about web services, web map services, web feature services, web coverage services, and that's where they stop and start. There's nothing more. I wanted to point out that there are a lot of other standards in place. There are standards for sensors, be that a flood gauge, be that a soil moisture sensor, be that your cell phone, be that a drone, be that satellite. They're mature, implemented. A lot of processing services. So processing algorithms over the web. You build a model and you run it across the web. A lot of data models and encodings or content standards. So KML is up there, of course. So is Net, CDF, and the devices. All right, so this is, I'm probably singing to the choir here, but the need for information is pretty ubiquitous since it's growing. Here's a quick question for you. How many people knew in this room that OGC standards are part of aviation standards? They are. Through some of the standards for weather, for aerodromes, for aircraft identification, there are elements of geography market language in there. So we work really closely with the FAA and Eurocontrol. What's cool about this sort of stuff, these are quote non-traditional geo actors who have now understood fully that they must embrace this and do it in the standard way. The other examples we're all probably pretty familiar with. All right, so once again, I'm singing to the choir. The old days, not too many data sources. The new days, ubiquitous now. And in order to manage all of this data and information, it's going to require some thought about how to include standards properly. Standards make for sustainable longer-term operations. This is a point that came up this morning as well from what Steve said. One of the biggest challenges that remains today is cross-community information sharing, cross-border information sharing. This is one of the biggest challenges. So I found it really interesting when you mentioned that one of the goals here was to start building some more relationships to handle cross-border stuff. We've done, a number of pilots across borders, but every one of our test beds, which is our basic one, always has a cross-community interoperability thread. Policy is a critical part of this as well. These are just some examples of policies that have been made, including the US and many other places. And we've got a lot of challenges coming our way in what's happening in the future. I think we're all probably familiar with these. The Internet of Things is pretty topical right now. Indoor frontier is also really topical. How do you come from outside a building and wander into the building and still be able to navigate on your device? This is useful for emergency responders, it's useful for retailers. We have a member by the name of FedEx. So why do you think FedEx is a member? And it's not Rudy. They solved the never turn left problem many, many years ago. They lose their couriers. A courier will go into a large building and the package will say, delivered to Tower B, room 13-792476. And then an hour later, the courier emerges, having not yet delivered the package. So the FedEx interest is how do they make sure that when they're navigating within these large buildings that the couriers know in advance where they're going. Because an hour's lost time in the FedEx or the courier business, given the competitive nature of it, adds up to a lot of money over time. But it's a pretty cool application. Smart cities. This is another one along with the IoT where there's so much stuff out there that, frankly, it's become, when you say the Internet of Things 3 or 4 times, what does it actually mean? Same with smart cities, future cities. However, the community, the OGC community, is working to actually say, well, this is how you manage location information amongst many different devices or the Internet of Things. This is how you get smart in your city, using real-world use cases. All right, so OGC, ISO, and IHO, which is the International Hydrographic Organization, were asked by the United Nations Geographic Information Management section, which sits under the stats section, to create a technical guide or a non-technical guide that people who weren't geo could understand. What the heck are these standards guys talking about? That wasn't super technical. So what this ended up in is a plain English guide, which I'll walk through shortly, and a companion document that has more technical details. All right, so the group, which this was quite the effort. I was the OGC staff lead on managing this one. We had 67 to 70 authors, and at any given moment, some days it was 10, other days it was the full crew. You know how difficult it is to get 70 people to agree on a common framework? Well, they did. They put together what they call the maturity model. I don't quite agree with the fact that they labeled it a maturity model because things are moving so quickly that maybe they should have called it an evolutionary model, but the consensus was to stick with the maturity model. So with Tier 1, share maps over the web. Tier 2, geospatial information sharing partnerships. Tier 3, national, international, and regional STI. And 4 is anticipating the future. Organizations can be almost anywhere on this spectrum. It's going to depend on the organization. Okay, so Tier 1, share maps over the web. That doesn't sound too exciting. We do it all. You know, it's been done for a long time. People want to discover and view interactive maps on the web. Organizations understand, describe, collect, and manage geospatial information, and then basically view and query these. So the standards associated with this are visualization, portrayal, and discovery catalog. So why do this? Well, it's low cost. Information may be stored in more than one system using different technology, so it's technology neutral. Since information and data is not copied, it stays close to source. There's no or little need to incur any sort of conversion costs. Data remains with the owner, and then you can publish maps with them to the citizens. And for organizations that are unable to distribute, they're willing to share pictures of the data. The web map service is simply a snapshot of data. It's not actually data, for example. Policy and governance are minimal. It can be completely informal. You can just talk to your opposite number the next day over and say, hey, let's stand up a web map service to show something. A good example of that that's just beginning to happen right now in Canada is the Fort McMurray fire has crossed the border into the province of Saskatchewan. So they've fired up a joint portal to be able to visualize that and manage resources. You know, it's only a meager 5,300 square kilometers big, that fire is. But once again, cross-border stuff. They're doing it informally. They just picked up the phone and said, okay, expose your, tell me what your OGC services are, and then away they go. Some examples: India, zoomed into New Delhi. Chile, geological maps. Ministry of Energy and Mines, British Columbia. Once again, these are all examples where organizations have used open source, organizations have used vendor tools. They work in good harmony. Won't go through this long list of things. One point I should have made is OGC and ISO have a unique relationship whereby OGC standards are fast-tracked through the ISO process and become ISO standards, and vice versa in certain cases. What's interesting about that is OGC standards are free. Anybody in the world can download them, but if you want to go to ISO, you got to pay. Even though it's the same standard, so just come to OGC. And some catalog discovery. This copy of this presentation will be distributed after this?
Yes, it's being recorded actually.
Okay, cool. So that fraud in my throat appeared at the wrong time. Geospatial information sharing partnerships. Communities want to publish their information on the web, to build, share, and use data sets to provide a common view of important issues, navigation, flood, road maintenance, disaster management, call it an information community if you want. Data providers do not need to adopt the same technology solutions or change their database structures, provided that they agree to use the data model. And people can access, view, distribute, download, upload data. Okay, accessible over the web. It improves efficiency. Different organizations can query, exchange, and share the same data, even though their applications might be different, because it's forms a nice aggregated view. Metadata to provide context, provenance, and data quality continues to be an area that's of critical interest to many people in OGC, because without the provenance and data quality, it's difficult to determine what the fitness of use is. However, we start moving into the realm of more formal geospatial policies and practices, where organizations, cooperative organizations establish MOUs or liaisons or whatever their mechanism is. All right, so a couple examples. The IHO Worldwide Electronic Navigation Chart Database is at a tier 2. GeoNode, which is an open source tool for collaboration, is also at tier 2. In this case, it's used by Latin America and Colombia for sharing geospatial information. Standards list. I won't go once again and read the list of the standards. I do want to point out that at tier 2, we begin to see a combination of technical standards, such as the web feature service, the web cover service, but we also start getting into the realm of content standards, or model standards, if you will. So OGC's city geography market language is specific to, obviously, cities. Land administration, classification, geosci, water, there's a long list of these. In the IHO context, there's the S100. There's also indoor market language, pipeline market language, and a bunch of other ones as well. Tier 3. So it's especially enabling the region, the nation, but it could easily be a region or a sub-region. So, to get to this tier of maturity or evolution, you share foundational geospatial information. I'll mention what that means a little bit later. Once again, contributes to evidence-based decision-making, multiplies the value of geospatial assets. It's a classic way of doing the old collect once and maintain once, and share many, many times. Foundational data, very straightforward. This is an example from Australia and New Zealand. The community sits down and agrees what are the basic layers that we need for our national, regional, whatever you want to call it, SDI. Data is owned by different partners, so there's no warehouse. So once again, update once, share many times. So we have, in this case, geocoded addressing came from one department in Australia, place names managed by somebody else, elevation and depth managed by somebody else, line code. start from absolute scratch or build on a domain-specific activity, such as city market language or water, includes geoprocessing over the web, delivery to multiple platforms, mobile, desktop, watch. Sensors start to be incorporated in a big way. So real-time data from a variety of sensors. The Alaska Ocean Observation Service is a heavy user of ODC standards for automatically and easily collecting data from their tens of thousands of buoys and sensors that are floating around in coastal and ocean areas. Policy frameworks are really robust at this point. It includes things like surface level agreements so that department or organization A promises that they will update data layer X once a year or once or however long it needs to be done. And as a result, you get a cooperative maintenance of all of the data layers. Example, CGDI, Canadian Geospatial Data Infrastructure. France Geoportal. Norway Digital. The Norwegians have done some insanely amazing work. You can go from a national map in Norway right down to street level individual data layers in cities for everything, pretty much. Of course, it's a smaller country, sort of, but they've bought in wholesale. An example, web processing service. This e-habitat was basically a way to allow multiple participants, in this case EC-based, to run ecological modeling and share their models. In the realm of sensors, we have an OGC member in Taiwan. Taiwan suffers from sudden and very, very rapid flash flooding, which turns into really nasty debris flows. So what they've done is they've censored up something like 35 or 36 basins that consists of everything from CCTVs to video cameras to water gauge level instruments to soil moisture, so that when an event happens, the operations center is immediately notified, and then they can do something about it, which includes notifying the public, it includes sending out mobile assets, it includes involving first responders. This runs 24/7 and is completely operational. They also have the ability to, in a standards-based way, task satellites, should they need to do that. Okay, so this is probably OGC's smallest standard. It's one page. Honda in Taiwan is using GeoSMS as part of the roadside assistance package. And what GeoSMS does is attach location information to a text message. So if somebody's car breaks down, they send a text. The roadside people know exactly where they are. Simple. This one's actually also making its way through another standards development organization as a standard right now. Okay, here's the standards list again. I won't read this through. But if you're thinking about using sensors and you have a need to do it, I would start thinking about having a look at some of the OGC standards and the people who will implement the sensor standards. Tier 4 is the wild and woolly future. Cloud computing, linked data, big data, semantic web portals. I would actually change mobile devices for all devices. New and dynamic geospatial data collectors, people. It's, crowdsourced. Social media, VGI, and standards continue to emerge based on the trends. We also co-authored the document on future trends, 5 to 10-year vision. This is actually going through the process of an update right now. But the UN community identified the following list as the key trends: cloud computing, linked data, IoT, Internet of Things, new data creation, VGI, open standards, open source, and legal policy, coordination and collaboration and capacity building. Example, the Ordnance Survey in the UK is the first national mapping agency to publish geospatial information to the web of data through linked data. And the motivator to do this was policy at the federal level. The UK realized that it was wrong to sell, for a government department to sell data to people, because the people of the country had already paid for it once. Why should they pay for it twice? So, making public data issues. All right, coming towards the end. First bullet, this is absolutely critical. Back to the people point. Organizations must agree, and the people within those organizations must agree, commit and use standards into SDR. I would actually argue that maybe in 10 years we won't be talking about spatial data infrastructure anymore. We'll just be calling it data infrastructure, and location and spatial stuff will just be the core, or part of the core of that. On the other hand, there must be clear statements in policy. And when it comes to procurement time, the procurement language needs to basically say or encourage that vendors offer standards-based solutions. So that's the stick. So final thoughts. Well, standardization is a reason for success of the internet, e-commerce, and many, many more things. Technology changes organizational structures, workflows, and business models. And because things are changing as rapidly as they are, some new thinking about SDI roles and investments and commitment to interoperability is required. This is David Shell. He's the founder of OGC. Who here remembers an open source project called GRASS? He was the GRASS Foundation guy before he started OGC. So, in his words, interoperability seems to be about the integration of information. What it's really about is a coordination of organizational behavior, coordination of people, again. With that, thank you once again for the opportunity. I have a list of resources on the PowerPoint. And, OGC's key to success is our members and the people of our, people who represent those members. In terms of making progress, the more requirements we have, the better the community results. So thank you.
Okay, from the floor, do we have anyone who would like to ask a question? Oh, come on, Brian, I know you've got one that you want to ask. All right, here we go.
Yeah, thanks, Trevor. Brian from Fishon. For decades, I've actually watched OGC evolve. Actually, NRCS is one of your followers. But also, organizationally, after seeing your talking, I still see there's a problem because it's organizational members that drive the system. But also, and you can comment on that, but you're also talking part of your audience right here. But how do you not coordinate or collaborate, but how do you merge like GITA, the GIS societies, ASPRS? Because as a former center or primary data acquisition division chair for ASPRS, we never had a talk about sensors in 6 or 8 years about sensor development for airborne and satellite and so forth, but yet there's the overlap.
Right.
The question is how to bridge that.
All right, so let's go to the last part first. ASPRS and OGC have created an MOU. And we figured out the best way to actually do this was go and look at a single issue. That was important to both ASPRS folk and the OGC community, which was LiDAR standards, or point cloud standards. So we're actually working together on the next gen for point clouds. So that's a good step one. It's a good example of how we try to harmonize things. But I agree, historically, the connections haven't been particularly good. For your point about membership is by organization, your point is well taken. Having said that, the people who are most active in our member organizations are also the ones who contribute as volunteers to all sorts of different things. So you've got a representative, say, from Hexagon, who will actually go and help a domain working group that is not directly in the interest of their business. And that's okay. And that's how people understand that. We do have an individual membership category. The problem with the individual membership category, and the reason why we are members by organizations, it's got all to do with intellectual property rights. Okay, we need to make sure that during the process, somebody else's intellectual property doesn't end up in a stand. So, we do have the individual level, but that individual level really is intended for sole, one person who hasn't signed away their IP rights to an employer, so it's different. We have been requested to look at certification for individuals and certification for organizations from a capacity perspective. But that will emerge sometime in the next couple of years. We do need to change that a little bit. Your point about GITA and GISP and all that sort of stuff, that's a good one. Should there be a consolidation of organizations, or should there be a more formal way to deal with this? I don't have an answer to that question.
Okay, anybody else? Okay, once again, thank you very much, Trevor. Greatly appreciate it.